So the this is the first, I mean, the first thing here that you have to decide when you're looking at this problem is whether it's a law of sines or a law of cosines. And there's not really a way to know as a student until you've done way too many of these by looking at it. But eventually you figure out which ones are and which ones are not. This one is, we got 327, 251, 72 degrees, 40 minutes. Is this a law of sines or law of cosines? And do you know how to decide, I guess? It's
Um,
okay if you don't, I can explain through it, but that's an
I
important
know
part of this.
the sorry, I have like a list of equations. I just don't have it out right now.
That's okay. That sounds really complicated. Law of cosines is side angle side or side side side. So if you have the angle between two sides, it's always law of cosines. If you all have all three sides, it's the law of cosines as well. For law of sines, you need a side and an angle pair. Basically, you need a side and the angle across from the side to use law of sines. So this one's a law of cosines problem.
Mhm.
It is never a two triangle problem. You typically only see those out of law of sines.
Okay.
There's also the none possibility. That's why I was asking if these are mixed up or if you knew, because I can pick some that are if that's what you want to do here. So the next thing
Yeah.
here is figuring out the other stuff. Like when it says solve each triangle, like your final answer is little a, little b, little c, big A, big B, big C. And I would love it if it was organized in a table if I were grading your so I would recommend maybe organizing your results in a chart like this if you want. That's
Hmm.
up to you. You already have half of it. It's not like you got that much more to do. Now, when you're given side angle side, you're always solving for a side. When you're giving side side side, you're always solving for an angle. So, like you were about to mention, there's three formulas here, but there's really only one formula for law of cosines. It's just that they rewrite it depending on what you're solving for, um, whether that's the sides or the angles. So it actually starts out as the Pythagorean theorem. That's how you can memorize it if you don't want to, not sure how to remember that. And then you subtract two, and it's the same two letters on this side, cosine of the letter across from the side, like that. So even if you want to use the other variations on it, like b squared equals a squared plus c squared, it still follows the same pattern where these two letters on the right are written next cosine of the angle across from the sides. That b and b match up like that. That's how I remember it. Like I don't have any special powers. I just uh,
Yeah.
you gotta write this in the right order here. And so on. So we're using the first one though, and you have everything that you need. So your setup here, and it is calculator is what did I grab 30? So 327 squared plus 251 squared minus 2 times 327 times 251 cosine of 72 plus 40 over 60. That's the conversion from minutes to degrees. And it would be really, really amazing if you could put all this into your calculator at one time, because that's what the calculator is designed for. It actually isn't designed to do it like piece by piece. It can handle all of this. And better
Oh,
yet is
okay.
if you can take the square root of all this. I mean, why not really let the calculator do what it was supposed to do? But I'll leave
Mhm.
that decision up to you. Uh,
Why is it cosine 72 plus 40 over 60?
So you have to convert it from minutes to degrees. Like that.
Oh,
So,
okay.
so the 40, it's 60. Why doesn't it like this? All right. So it is kind of taxing to put this in a calculator. Like you have to just be very patient. And
Yeah.
so common mistake that students make is they don't realize that they have to take the square root of their final answer there. That's why I said it's even better if you can do it all at once. So it ends up being C ends up being about 348 in this problem.
Okay.
All right, so now that's what I was talking about, like filling in the table. Like this is 327, this is 251, and this is now 348. So you try and you should only use law of cosines one time. You should then, because now you have a side and an angle pair, you should then switch back to law of sines.
Okay.
So let's do that here. Um, so let's find I mean, it doesn't really matter. Let's just find A. So the sine of A over little a equals the sine of C over little c. You know that also comes in a bunch of different formulas, sine A, sine B, sine C. You're always just pairing up two of them. And you can put the thing you're trying to find in the top. That's generally preferred. All right, so sine A over 327 equals sine 72 plus 40 over 60 over 348. And then you can solve for A by clearing out that fraction. And then you can undo sine with sine inverse. Now, I tend to write the coefficients in front. It's a little less likely to make mistakes. So A is the sine inverse of this. Oh yeah, other thing, make sure your calculator mode is in degree, not radian, especially if you're switching between classes. You got another class for
Okay.
using your calculator, you might see that. So I got 63.8 degrees. And this is where you would check for two triangles. This is the part you were asking me about.
Yeah.
So what you do is you take that answer, you subtract it from 180, which is 116.2, and then you add in the known angle. So your known angle is 72 plus 4/6, and you decide if there's still room. Basically, like, is there room for a third angle to get to 180? You will find that these two numbers add up to be greater than 180.
Okay. That makes. Will we not have to convert 63.8 back to minutes?
Only if the question said so. I mean, I sure hope. I sure hope not. I mean, it's like an unnecessary step.
Do you know how I'd do that if I needed to?
Yeah, so 63.8 is 63 degrees plus. So you take that 0.8 and you multiply it by 60. And you'll find that that's 48 minutes exactly.
How'd you 48 degrees? I mean,
48
48 minutes.
minutes. 0.8 times 60.
Okay.
Questions on that?
Mm, no, that makes sense. Thank you.
Okay. So the other thing here is that now that you found the other side, 63.8 degrees, and now we're going, well, actually, let me go back here. So now we know that this is 63.8 degrees. You do not use law of sines to find the third angle. You subtract from 180. You take 180, subtract 63.8, subtract 72, and 4/6. You
Okay.
find that's how you find the third angle. And
Okay. Could we not like because we got two of the sides and one of the angles, could we not like originally do sine 72.8 over oh wait no, because we didn't have that side, never mind.
that's right. I call it a side angle pair. You have to have a side and an angle across from it. See, and sometimes I feel like we come to our lessons and like you really need like someone needs to have made this really clear. Like the first thing is you decide whether it's law of sines or law of cosines, and then you go down these paths. But maybe you didn't, let that end of class there. All right, so let me look for a problem where it actually does give you what you're asking for. Which is this wonderful, you know, I think they call it some sort of case. I don't remember. All right. So here is a problem. You should consider always drawing the triangle exactly the same. A, B, C, or whatever the three letters are, kind of in the same orientation. You'll see me do that over and over again because I think it's simpler. Um, Something like that. Okay. So is this as you kind of look through this, is this a law of sines or a law of cosines?
It's love cosine,
So you either have all three sides or side angle side. Which do you have here?
side angle side.
So I see a side and an angle, but I don't see the other side. We're missing that one.
Oh, it has to be. It'd be lost signs, and then you could
Yes.
do the
So a lot of sines, you've got what I keep referring to the side angle pair like that. Um, and then you use the other side to find the missing angle there. So in this case, the sine of C over 26 equals the sine of 70 over 25, like that. So could you attempt to solve for C, please?
0.97. I mean 0.98.
It sounds
And
like you
then,
solved for sine C, not C itself.
oh,
So
do you want C itself?
yeah, we actually don't. It's useless. You know, it sounds bad, but it's useless to give.
77.8.
There we go. That's what we want. Okay, so this is where you said 77.8. This is where you have to check. And so the first thing you do is you subtract the angle from 180, which is 102.2. Then you add the other angle, the one that you started with, and you decide if there's room. Basically, is this less than 180? Yes, it is.
Okay. So then that would have two solutions.
Yes, and this is where it's kind of frustrating is you got basically two problems, which means you will get a triangle that has no solution, no triangle. But you've got to say, okay, I've got a C, which is 77.8, and then a C prime, which is 102.2. And so you have to then solve for the rest of the triangle under both of those conditions. So let me I guess I need to redraw it here. It's okay, so 77.8. So you can pretty quickly find B next, big B. You add the three angles to get to 180. You do the same thing to find B prime. So the steps are really similar. It's just the different numbers. So B is subtracting from 180. So I'm sorry, not adding up the two angles. Subtract 180. So 32.2. If you want a visual of what the other triangle looks like, because sometimes I think that could be useful, is it ends up being um, an obtuse angle for C, 102.2. That could help, maybe. So that missing angle is like 5.8 degrees. And it's up to you if you want to solve them like side by side, or if you want to, solve one and then come back and solve the other. Any questions on that before we find little b?
No, that makes sense.
All right, so little b, you use law of sines at most twice. In this problem, use it twice to find little b. So b over sine big B. And then you have your choice of whether you use A or C. I always like to go back to the given information, just in case, you made a mistake somewhere. You might find that that doesn't work against you too bad. So then we throw in the numbers here. So B over sine big B is 32.2 equals A 25 over sine 70. So you clear out this, multiplying both sides. So B equals 25 sine 32.2 over sine 70, like that.
Does that, wouldn't it, the sign, can sign be on the bottom or does it have to be?
Yeah, it can be on the bottom. You're multiplying. So that's where maybe in class you guys have been like recalculating these, but your calculator should do it. You should let your calculator do it all at the end. If you are going to pre-calculate, go out to like 4 decimal places, maybe more. All right, now to find the other b, it's really similar. I mean, it's actually the same calculation. The only difference is the angle. But if if you're ever like, oh, what is it? You just write the same thing. So b over sine, um, what is the angle? 5.8 equals 25 over sine 70. And kind of to answer your question, what you're doing is you're multiplying both sides by the sine of 5.8. That's why it still remains on the top and the bottom. Like that. B ends up being, well, over here it was 14.2. Here it ends up being like
2
2 points.
2.67 or
Yeah,
69.
yeah, sure. So check with your instructor on rounding. Intermediate answers should not be rounded. That's why another reason why you should put it all in the calculator at the end. But that's up to you.
Okay.
All right. We should cover the other possibility, which is not a triangle. Is that okay?
What?
We should cover the other possibility, which is no triangle.
Oh yeah.
And that's why they give you one that has two solutions, because they always give you one that has no solution to kind of average out to that. So if you draw the triangle again, A, B, C, 73, 7, 1, 5. Is this a law of sines or is it a law of cosines? As you kind of work it out there visually.
That would be sine.
Law of sines, yeah. So you can find angle A this time. Sine of A is across from the 7, equals sine of 73 across from the 5. So again, very important that you actually solve for the A. You'll notice the patterns here as you do more of these.
I'm getting error.
Yes. So when you get an error, the first thing you should do is recalculate it. And the reason you recalculate is because sometimes you make errors as just putting it in the calculator. But in this case, the reason it's an error is because there's no triangle. And the reason there's no triangle is the number inside parentheses has to be between -1 and 1 for it to work. Because sine, if you remember the sine, it's bounded from 1 to -1.
Yeah.
Okay. So from here, it's just a matter of, okay, we're going to do a lot of problems. One that we have not done tonight is a law of cosine solving for an angle, um, which we could do next. What would you like to do from here?
We can do the solving for angle.
Okay. So I'm gonna grab C. I'm sorry, 36, not C, 36 from your paper. And
Hey, could we do the problem that's like if there is a second solution, find the sides and angles of that second triangle?
I have to do that, I have to find one that has two solutions. We kind of did that earlier, but yeah, we can do that. But uh, do you want me to look for one then that has two solutions?
That'd be great.
Okay. So it's going to be law of sines though.
Okay.
That's I mean that's kind of the nature of these things. All right, yeah, this one has two solutions. 45, 28, 27. Okay, could you solve for angle? Yes. Angle A. Angle A is the first one to solve for.
It would be lost signs.
Right. Yes. So yeah, go ahead and solve for angle A.
Forty-seven
Say that
degrees
one more time.
for A.
You said 47?
Yeah.
Yeah, so A is 47.2 degrees, and then you can subtract it from 180, which is 132.8. Do you remember what to do from here to figure out if if there's a second triangle, like what you do with this number, 132.8?
Um, Not really.
So you add it to you have to add the other angle, the 45, because that's fixed, and you have to see if there's still room. Meaning is the sum less than 180?
Okay. It is.
Yeah, there is room.
Yeah.
It's only 177.8. There's just got to be a little bit of room. So there are two triangles here. So you don't have to redraw it or anything like that. Um, you just have to solve for the missing side. So or angle. So in this case, it really is only C that you're gonna have to solve for. You've got to solve for C using, the little angle A and then the bigger angle A.
So you would,
So you use law of sines to solve for C. Like what would you write? You'd write C over sine big big C, which you have to get big C now from subtracting the two angles from 180 for it. Maybe we should do that first. Can you get me the third angle C in this original case?
The angle of C?
Well, if A is 47.2 and B is 45, what is how do you find the third angle? Well, they all add up to 180.
87.8.
Let me just double check. Yeah, 87.8. Okay. So now to find little c, the side little c, you need to put it over sine big C. And then you have a choice of whether you use, B, angle B and side B, or angle A and side A. I would always go back to the given information. I would use little b over sine big B. You want to try solving that for little c. You have everything now. You have the angle C, 87.8. Little b is 27. Angle B is 45.
$38.
Yep, 38.2. And then you do the same thing to find C prime. You just have to use the other angles. So we have not calculated the big angle C yet. And that's where you might want to make tables to make this more organized. But you only get one problem on this on the test usually. But the second angle C comes from, okay, first angle A, or the A prime is 132.8. You still use the 45. Sorry about that. Still use the 45 up here. What is the big angle C?
Um, wouldn't it just be 87.8?
Nope. You have to recalculate the new C for the new A. You have a big A prime of 132.8. You know B is 45. You add those together and subtract from 180.
Is B still 45? Like that
Yes,
doesn't.
that never changes. The given angle will never change. The given sides will never change. Only the
Oh,
potentially the calculated sides will change.
it's 2.2 degrees.
Yes. So now you reuse, now you have to solve for C prime. You have to use big angle. Big angle C, so that 2.2. So you're doing the same calculation you just did for the 38.2, except you're using that big angle C there.
Point 73.
Uh, Bigger than that. So C prime ends up being uh, little b, which is 27 over sine 45 sine of 2.2. It's a little bit bigger than that. Maybe just didn't quite get the numbers in right. And there's not really a way to know if they're reasonable or not, truthfully. They're just
1.5.
yes, very good. So like what I was suggesting here, let me try to show you that, is the way to kind of organize it. I mean, there's so much going on, but the way to kind of organize it is you've got an A, a B, and a C, a little a little b, a little c. And then over here, you ended up having an A prime, a C prime, a little b, and a C prime. And like some of them are the same.
Is there no little a prime?
No, if it's given, it's not
Oh,
gonna
oh yeah.
change. Okay. And you calculate the other ones. That's how I would force the students. I would actually put a table in. I'd just give you enough room to organize it. Because I think organizing your answer is important here. It's really two different flows, uh, also project flows,
Okay.
problem flows. Okay. So let's see if we can quickly do a law of cosines type problem. I was actually needing to stop in a couple minutes, but let's see if we can get this one done pretty quickly. 36 on your page. Because again, there's kind of like an issue of like, well, how do you solve for the angle? So, all right. Law of cosines, typically only one triangle here. A, B, C, 4, 5, 8. You can actually solve for any angle that you want. So you might just stick with the standard c squared equals a squared plus b squared minus 2ab cosine big C. And then I would not try to remember the formula for cosine C. I would just solve it here for it. Um, you end up moving the a squareds over, the b squared over. And then you divide by the minus 2ab. Now you'll see in some textbooks they manipulate signs here, like they put the negative up here. It doesn't really matter if you do that or not. It's up to you. The calculator will handle all this, so you don't have to worry about that. And then the last thing is to take the cosine inverse.
Okay.
So we've got those three values. We've got A is 4, B is 5, and C is 8. Could you calculate big angle C? Just and in your calculator, there's gonna be parentheses in the numerator, parentheses in the denominator.
I got 125.
That is correct. So now you do not use law of cosines. You're done with that. You only use it once. Very important to remember that. That'll save you some time. Let's just solve for angle A. So sine A over 4 equals sine 125 over 8. You can solve for A. It's the sine inverse 4 over 8 sine 125. And so that ends up being about 24 degrees. Now you can do the whole thing where you subtract from 180 and you get 56 degrees. But when you add the other one here, 125, you realize, oh, that won't work. So there's only the one triangle. And then to find the third angle, you just subtract from 180, the two other angles. You never use law of sines again. If you do, you'll be like, why did I do that?
Okay.
All right, so I hope that helped. I'd like to stop here for today. And